Acquiring and installing Kali Linux. Armand Shahriarian. Acquiring and installing Kali Linux. The easiest way to acquire Kali Linux is to visit its website. From there, you can gather additional information about the software, such as lists of packages that are installed. You will be downloading an ISO image that can be used as if you are installing into a virtual machine, VM, or it can be burned to a DVD to install to a physical machine. Kali Linux is based on Debian. This was not always the case, at least as directly as it is now. There was a time when Kali was named Backtrack Linux. Backtrack was based on Knoppix Linux, which is primarily a live distribution, meaning that it was designed to boot from CD, DVD, or USB stick and run from the source media rather than being installed to a destination hard drive. Knoppix, in turn, inherits from Debian. Backtrack was, just as Kali Linux is, a distribution focused on penetration testing and digital forensics. The last version of Backtrack was released in 2012. Before the offensive security team took the idea of Backtrack and rebuilt it to be based on Debian Linux. One of the features that Kali retains that was available in Backtrack is the ability to live boot. When you get boot media for Kali, you can choose to either install or boot live. In Figure 1:1, you can see the boot options. Figure 1:1. Boot screen for Kali Linux. Whether you run from the DVD or install to a hard drive is entirely up to you. If you boot to DVD and don't have a home directory stored on some writable media, you won't be able to maintain anything from one boot to another. If you don't have writable media to store information to, you will be starting entirely from scratch every time you boot. There are advantages to this if you don't want to leave any trace of what you did while the operating system was running. If you customize or want to maintain SSH keys or other stored credentials, you'll need to install to local media. Installation of Kali is straightforward. You don't have the options that other distributions have. You won't select package categories. Kali has a defined set of packages that gets installed. You can add more later or even take some away, but you start with a fairly comprehensive set of tools for security testing or forensics. What you need to configure is selecting a disk to install to and getting it partitioned and formatted. You also need to configure the network, including host name, and whether you are using a static address rather than DHCP. Once you have configured that and set your time zone as well as some other foundational configuration settings, the packages will get updated and you will be ready to boot to Linux. Fortunately, Kali doesn't require its own hardware. It runs nicely inside a VM. If you intend to play around with security testing, and most especially penetration testing, getting a virtual lab started isn't a bad idea. I've found that Kali runs quite nicely in 4 GB of memory with about 20 GB of disk space. If you want to store a lot of artifacts from your testing, you may want additional disk space. You should be able to get by with 2 GB of memory, but obviously, the more memory you can spare, the better the performance will be. There are many hypervisors you can choose from, depending on your host operating system. VMware has hypervisors for both Mac and PC. Parallels will run on Macs. VirtualBox, on the other hand, will run on PCs, Macs, Linux systems, and even Solaris. VirtualBox has been around since 2007, but was acquired by Sun Microsystems in 2008. As Sun was acquired by Oracle, VirtualBox is currently maintained by Oracle. Regardless of who maintains it, VirtualBox is free to download and use. If you are just getting started in the world of VMS, this may be a place for you to start. Each works in a slightly different way in terms of how it interacts with users. Different keys to break out of the VM. Different levels of interaction with the operating system. Different support for guest operating systems, since the hypervisor has to provide the drivers for the guest. In the end, it comes down to how much you want to spend and which of them you feel comfortable using. As a point of possible interest, or at least connection, one of the primary developers on BSD was Bill Joy, who was a graduate student at the University of California at Berkeley. Joy was responsible for the first implementation in Berkeley Unix of TCP/IP. He became a co-founder of Sun Microsystems in 1982 and while there, wrote a paper about a better programming language than C++, which served as the inspiration for the creation of Java. One consideration is the tools provided by the hypervisor. The tools are drivers that get installed into the kernel to better integrate with the host operating system. This may include print drivers, drivers to share the file system from the host into the guest, and better video support. VMware can use the VMware tools that are open source and available within the Kali Linux repository. You can also get the VirtualBox tools from the Kali repository. Parallels, on the other hand, provides its own tools. At the time of this writing, you can install the Parallels tools in Kali, but they're not fully supported. But in my experience, they work well even if they aren't fully supported. If you'd prefer not to do an install from scratch but are interested in using a VM, you can download either a VMware or VirtualBox image. Kali provides support for not only virtual environments but also ARM-based devices like the Raspberry Pi and the BeagleBone. The advantage to using the VM images is that it gets you up and running faster. You don't have to take the time to do the installation. Instead, you download the image, load it into your chosen hypervisor, and you're up and running. If you choose to go the route of using a pre-configured VM, you can find the images at the page on Kali's site for downloading one of these custom images. Another low-cost option for running Kali Linux is a Raspberry Pi. The Pi is a very low-cost and small-footprint computer. You can, though, download an image specific for the Pi. The Pi doesn't use an Intel or AMD processor as you would see on most desktop systems. Instead, it uses an advanced RISC machine, ARM, processor. These processors use a smaller instruction set and take less power than the processors you would usually see in desktop computers. The Pi comes as just a very small board that fits in the palm of your hand. You can get multiple cases to insert the board into, and then outfit it with any peripherals you may want, such as a keyboard, mouse, and monitor. One of the advantages of the Pi is that it can be used in physical attacks, considering its small size. You can install Kali onto the Pi and leave it at a location you are testing. But it does require power and some sort of network connection. The Pi has an Ethernet connection built in, but there are also USB ports for Wi-Fi adapters. Once you have Kali in place, you can perform even local attacks remotely by accessing your Pi from inside the network. We'll get into some of that later. With so many options to get yourself started, it should be easy to get an installation up quickly. Once you have the installation up and running, you'll want to get familiar with the desktop environment so you can start to become productive. Desktops. You're going to be spending a lot of time interacting with the desktop environment, so you may as well get something that you'll feel comfortable with. Unlike proprietary operating systems like Windows and Mac OS, Linux has multiple desktop environments. Kali supports the popular ones from their repository without needing to add any additional repositories. If the desktop environment that is installed by default doesn't suit you, replacing it is easy, because you'll likely be spending a lot of time in the environment. You really want to be not only comfortable but also productive. This means finding the right environment and toolsets for you. GNOME Desktop. The default environment provided in Kali Linux is based on the GNOME Desktop. This desktop environment was part of the GNU, GNU's Not Unix, which is referred to as a recursive acronym, project. Currently, Red Hat is the primary contributor and uses the GNOME Desktop as its primary interface, as does Ubuntu and others. In Figure 1-2, you can see the desktop environment with the main menu expanded. Figure 1-2. GNOME Desktop for Kali Linux. Just as with Windows, if that's what you are mostly familiar with, you get an application menu with shortcuts to the programs that have been installed. Rather than being broken into groups by software vendor or program name, Kali presents the programs in groups based on functionality. The categories presented, and ones covered over the course of this book, are as follows: information gathering, vulnerability analysis, web application analysis, database assessment, password attacks, wireless attacks, reverse engineering, exploitation tools, sniffing and spoofing, post-exploitation, forensics, reporting tools, social engineering tools. Alongside the Applications menu is a Places menu, providing shortcuts to locations you may want to get to quickly. This includes your home directory, desktop directory, computer, and network. Next to the Places menu is a menu associated with the application with a focus on the desktop. If no program is running, there is no menu there. Essentially, it's similar to the taskbar in Windows, except that running applications don't line up in the menu bar at the top of the screen. The only one you will see there is the application in the foreground. As in other modern operating systems, you'll have a little collection of icons in the far right of the menu bar, which GNOME calls a panel, including a pull-down that brings up a small dialog box providing quick access to customizations, logout, power functions, sound, and network settings. Figure 1 to 3 shows this dialog box and the features supported through it. Mostly, it provides quick access to system functions if you want to use menu actions to perform them. Figure 1 to 3. GNOME Panel Menu. Along with the menu in the top panel, there is a dock along the left side. The dock includes commonly used applications like the terminal, Firefox, Metasploit, Armit, Burp Suite, LeafPad, and Files. The dock is similar to the dock in Mac OS. Clicking one of the icons once launches the application. The options in the dock to start with also show up as favorites in the menu accessible from the panel. Any program that is not in the dock will be added to the dock while it is running. Again, this is the same behavior as in Mac OS, whereas Windows has a taskbar that includes buttons for running applications, and also has a quick launch bar where you can pin application icons. The purpose of the dock in Mac OS and GNOME is to store the application shortcuts. Additionally, the Windows taskbar stretches the width of the screen. The dock in GNOME and Mac OS is only as wide as it needs to be to store the icons that have been set to persist there, plus the ones for running applications. The dock in Mac OS comes from the interface in the Next Step operating system, which was designed for the Next computer. This is the computer Steve Jobs formed a company to design and build after he was forced out of Apple in the 1980s. Many of the elements of the Next Step user interface, UI, were incorporated into the Mac OS UI when Apple bought Next. Incidentally, Next Step was built over the top of a BSD operating system, which is why Mac OS has Unix under the